I would like to give everyone that is attending a warm IFM welcome. Johan, can we just do a video quality check, please?
Good morning, Anthony, and good morning to all the attendees. I can confirm everything looks good. Thank you.
Thank you, Johan. I am Anthony Hitler, Regional Manager for the Coastal Regions of Southern Africa. The topic today is RFID track and trace, a hot topic in all industries at present, as an enabler of the OEE conversation. Note that this webinar has been recorded. Please make use of the Q&A section to post any questions or make any comments. On our website, you can access all previous webinar webcasts, recordings, Q&A documents and presentations, very importantly, in PDF format. So you can actually view this content in your own time as well. So what we'd like to cover today is IFM Electronics RFID product offering. And in order to do that, we need to actually give some reasons why RFID will be installed into manufacturing processes or smart manufacturing processes. We need to discuss OEE and RFID applications for RFID, some product selection tips, technical insights, and Ilink, most importantly, and RFID, a small demonstration just to get you started and thinking towards the new technology. There are many reasons that we would implement RFID into a business, factory, or warehouse. The most common of these is tracking and tracing of people. For example, the time and attendance, or products in transit, or the current phase of a process are good reasons to actually integrate RFID. The most common everyday use of RFID can be found in the retail space. RFID is used to ensure that high-value items do not leave the shop unintendedly or are stolen. So everyone's familiar with those little square boxes as you leave the shop and the tags on the clothing, etc. So RFID is quite common out there, so it's not new technology. What is new is the thinking of RFID integrated into the shop floor or the production area. So RFID can be used to measure the overall equipment effectiveness, or OEE, and auto ID of assets or people is the gateway to the next level of use of RFID. So what is OEE, or overall equipment effectiveness? In the tough global market, especially during this pandemic, the OEE conversation is a very big part to play in business and industry. There's a renewed focus towards efficiency, profitability with implementation of lean manufacturing. OEE is an enabler, at least, of clear metrics that can be attributed to lean manufacturing. In order to gain control of anything, you need to start by measuring all the dynamics of the situation, and this is where RFID comes in. The who, the why, the where are only answered when they can be identified. What does a lean or OEE manufacturing model look like? So you can see in this, the slide, there's a total cost of ownership on the top, and it drills down. But the KPIs of OEE are represented nicely, I think, in this table. The main highlights are machine availability or uptime, machine performance, looking at the actual performance versus the design of the machine or plant. Quality, how much product is accepted versus how much product was actually produced. What are we wasting as the result of that? And of course, then we got electrical energy, compressed air, raw materials, and the ability to get an informed overview of what's happening with regard to production and performance. The first application, most common of these days, is RFID. For RFID is machine access control. Once implemented, we can start to answer the questions who, when, and why. For example, smart tooling. So on a CNC machine or CNC milling machine, a tool can run for a certain amount of hours in a sharp state, but after those couple of hours or the number of work pieces rather that it's been applied to, the tool is less sharp and is going to not give you the same tolerance. So the RFID tag will monitor how long that tool has been in use for, and be able to actually give the operator an overview of when the tool actually needs to be replaced. Well, another example is on a filling or packaging machine, there normally are a number of different kind of volumes or sizes that one machine can produce. In order to change a machine, you need to reset positions of parts and remove and introduce other parts. This you can imagine or understand can be a time-consuming process, as well as you can basically say the machine needs to be recommissioned after this change is made. So you're basically starting from the beginning, and it can be lengthy, and sometimes the marketing departments of these companies want different sizes run, and the poor technical team are given very, very short notice to make these changeovers and work well into the night. With RFID, we could tag all the change parts and the positions that the parts are in, but perhaps relative to the volume or size of the products that will be produced. After the changeover, at a push of a button, the correct configuration can be then verified through RFID readers monitoring tags that are in place. So what will this guarantee? This will guarantee the machine will run after the changeover and produce a good quality from the start with the new volume or size, and no crashes will be experienced that can actually cost a lot of money in the long run. So on the slide now is a whole pile of different applications and, making a plant real-time visible, etc. The possibilities almost endless. We recently solved an application, and once RFID was implemented, the process of trucks entering and exiting a plant, the loading and offloading was completely automated and paperless. So how the system works is the truck entering the plant has a RFID tag on and enters the weighbridge, the entry weighbridge. So the entry weighbridge will then capture the tare weight of the truck, and an invoice number will then be also written to the tag. The invoice number is related to the actual grade of product that needs to be loaded, and the truck can be directed by the RFID tag and readers throughout the plant to exactly where it needs to load that particular grade of product. So once the loading process starts, the tag is obviously verified to start the process, and then the loading process starts, and once it's finished, the belt scale value can then be sent to the tag or written to the tag. So then the truck can proceed to the exit wire bridge. It's weighed once again with the material or product inside, and it can then exit the plant successfully. So on exit, the tag will actually, because it's got all the right, it's been through the right path, it's been pre-weighed, then filled, then verified after filling. It can then exit the plant without any other intervention. The boom gate will just open automatically. Then it can transit to the port or terminal, where the tag will be read once again, and all the weight and all the information on the tag can be loaded into the system. It can be given then a clear direction where to offload, and the date and time will be captured, especially in the case of a stockpile, so that product can be tracked when it's reclaimed again. And then, the tag can be cleared and the process can repeat. So quite a nice application. Other examples are work in progress or tracking of real-time shop floor progress. There are also opportunities to implement 2D and 3D code readers that we have also in our product range. If RFID is not accepted for this, or is not a possibility for this application, which is really, there's not many situations where RFID is not suitable these days. The cost of actual implementation has come down over the years, and that's what we're demonstrating here today when we show you the Ilink products. So in terms of implementation, we must consider the cost, the initial cost, because we've got many systems with RFID. So the cost of what the initial installation will be, the features, the functions, and what you'd get at the end of the day, and the cost of the long-term ownership needs to be considered, and the speed and ease of integration and the acceptance by the technicians and people that would work with the system on a daily basis to maintain it needs to be considered. So here's a quick overview. This is a snapshot of the website. What you'll find if you actually go on our website, go into products, go to identification systems, and click on RFID, you'll get this overview. And what you'll see here is there's various ranges of RFID readers and writes, antennas, readers and write antennas or controllers. The first range is the 13.56 megahertz range, or HF, or high frequency systems. And these use tags with the ISO protocol on, or ISO protocol on, and you can obtain ranges from 10 to 250 millimeters read-write with these antennas and tags. The other system is the UHF system. So this works on the 900 or 800 megahertz frequency, and we use the EPC Class 2 Gen 2 tags to read distances up to 10 meters with these tags. And you could even go beyond that distance with the correct tag implementation. So we're ready for your application. We've got a whole pile of products, but when to choose what? So on the left-hand side, you've got the UHF, which speaks for itself, and the right-hand side is all the HF stuff. So the UHF, generally where you have long reading distances, it's clear that that's where you will use that system. So the short range reading distances, like I said, up to 250 mils, then you can choose from a number, the other part numbers. So a further explanation of what these HF part numbers look like. So I need to just turn on my laser pointer to actually show you. So what the situation is, this is a read-write antenna, this is the controller. This unit can accept 4 of these antenna, or there's different variations of these antennas. This is just the biggest of the lot into this unit. And these units and the controller can be up to 20 meters apart. Okay. Whereas this unit here is one read-write head and controller all integrated into one unit. So you need to accept that there's an economy when using this set like this or the set like this. So where you would use this is where you've got 2 or more antennas in a very, very condensed area. Where you'd use the DTE6 is where you have multiple reading and writing applications, and they spread out further than 20 meters. Or there's possibly an economy that comes into play where you've got 2 readers that are about 20 meters or so away from each other, and it's a maximum of 2. The cabling, etc., may work out a bit more reasonable if you had to use the DTE6 versus the DTE1 series. I hope this makes sense. So then you need to look at the cost. So it doesn't mean to say the cost is not related to performance or functionality really, except for the UHF. The UHF is a much higher cost, but the advantage is the reading distances. The HF systems all have the same kind of reading distance advantages. It's just applying the correct system. So we're going to focus on the Ilink from here on in the presentation, but I'd just like to speak about a little bit about the tagging before we actually go on. So it's also important to choose the right tag. So in the HF systems, generally we've got about 180 or 890 bits, of data that we can actually transfer per cycle. In UHF, you've got 160 bytes of data that you can actually import on one read cycle. So you've got to weigh up how much data that you want to actually write and read from the tag at any one given time. So what we find and what I found out there is normally 4 to 8 bytes is generally acceptable. So the Ilink system can actually achieve most of the applications very effectively without the need to actually integrate the higher end options. So when choosing tags, it's important on HF, important to note the standard or the protocol. So we're using the 15692. So don't accept that because now I've got a 13.56 megahertz tag, I'm going to go and be able to read the time and attendance tags that I have on site. You could possibly read those if they are capable of achieving the ISO standard, the protocol that we use. Generally, the time and attendance guys kind of put their own proprietary protocol on their tags. Number one, to safeguard the information of the employees of the plant and allow the system not to be interfered with or jippered in any way. And the other is they would like consumable spares, which is a fair business strategy, I think. So those are some of the reasons. The other thing that you can see here is the memory bit size, 896. So that's the maximum memory bit size, and the number of blocks, and the block size. Each block size is 4 bytes, and the unique identifier. So every tag that's produced has a unique identifier. So for the same size tags from the same size manufacturer, it'll always have the same UID when it arrives after purchase. So then it's up to you to write your own unique number. So you identify the UID, you know the tag has been introduced, and you can write your own unique number to it thereafter. Then important to note the reading and writing distances of these tags. When we come to the UHF systems, we need to look at the following. Number one, we need to accept that the actual read-write head or antenna has a certain radiation pattern. So, okay, you can see the distances that it can actually, the radiation pattern can reach is up to 10 meters from these particular readers. Each one is a particular reader or size in this case, and you can see the width of the actual radiation pattern. So it's very important to note when you're actually putting down a reader, where is the object going to be detected? So then once you've considered what the actual reader can do, you also need to consider what the tag can do. So if we look at the radiation tag of the tags, we must accept that steel is a problem for RFID. You cannot see through steel. Stainless steel or mild steel or whatever the case is. Cardboard and plastics, yes, you can actually penetrate with the RFID signal through, but there's always need to test what the effect is of the particular packaging or plastic on the RFID reader. So it's important to note the radiation pattern so you can actually place the reader and the tag in the right place to reliably read and write to it. It's also important to actually make sure that there's no metal obstructing a line of sight. It's like normal radio comms, you know, you want a nice line of sight from reader to tag. Some HF or UHF applications, you could apply either system to this, product tracking, access control, asset management, material logistics, assembly stations, you know, like trays on a system. So For example, if you're producing refrigerators, you could actually track each phase of the process and actually make sure that it's correctly assembled on the line as the fridge moves along, and you could actually have an overview of exactly how far the production is of fridges, and when the complete manufacturing of one fridge or two fridges or whatever the case is completed, which is quite handy. But once again, distance, radiation patterns need to be considered when choosing the readers and tags. So this brings us to Ilink and RFID, which is a very exciting thing. So what is the introduction of Ilink and RFID? So firstly, I must say that these are the 13.56 megahertz or HF readers that have Ilink protocol embedded in, and we offer a simple plug and play and a cost-effective, seamless, fast integration. And this is what is actually driving the sales and the acceptance of Ilink and RFID. So what applications do we have in mind? Well, we've got the tool identification, which we discussed earlier, access control once again, pipe connection control. This is a really interesting one, that especially in the food industry, you have manifolds or swing gains that actually connects production vessels with storage vessels, for example. And there's one pump that goes up and down the floor, and you can connect flexible hoses to that pump to pump from the production vessel to the storage vessel. And if we put RFID readers on either side, on the storage vessel side pipes and on the production vessel side pipes, and we give the hoses tags, then we can identify where we're pumping to and actually increase the product safety, because also there's cleaning materials at play generally in these food environments. So you would be transferring, in 1 hour, you'd be transferring product from one tank to another, and the next thing you'll go into a cleaning phase where you actually introduce a pump that actually pumps caustic and hot water to actually rinse out the tags and do what we call CRP of the tanks. So it's important that the hoses are connected correctly, and Ilink and RFID can facilitate that. So what does a typical Ilink topology with RFID look like? Well, if you're familiar with Ilink, you're going to see no change. So I could have a pressure, conductivity, proximity, photoelectric on Ilink connected to one Ilink master, as well as an RFID reader to the next port. So there's complete flexibility now. So it's quite interesting that you can actually integrate Ilink to an existing application that you have on Ilink already. You're just going to have an open port that's available for Ilink and plug in the antenna of your choice with the appropriate reading distance for the tag chosen, and off you go. And then you can actually transmit that seamlessly, like we said earlier in the presentation. We are open to any of the actual PLCs out there. So whether it's Profinet, Ethernet IP, EtherCAT, or directly to the IT world, to a C# application, we have a reader with the appropriate protocol that will actually match your requirements. And then we can also, via the IoT port, send information directly to a cloud via MQTT, or to Edge Gateway using our line recorder software, etc., or directly to one of the clouds like Azure or one of the others. So we're completely flexible. What components do we need as a basic minimum to install a RFID reader on Ilink? So first of all, we need the read-write head. So if you just type on our website DTI, you'll get a few RFID Ilink options. They're all the part numbers for the readers and writers on RFID. They can be integrated into Ilink, start with DTI. All the other antennas will be DTA, interesting enough. Then you need a connection cable, a jumper cable that we refer to as M12, to connect this port to the port on the Ilink master of your choice. So you could use any of the four that are available on this particular unit. Then I need a power cable to power up the Ilink master with 24 volts, and then an Ethernet cable to facilitate from this, in this case, from the IoT port to a software that we call line recorder device. And this is what I'd like to demonstrate to you. So once wired, we have a situation that looks like this: a 24 volt supply, Ethernet cable to the software, and the read write head. And believe it or not, no PLC, but yet we can access the information. So there's going to be a brief stall in my presentation while I just change to show you a pre-recorded demonstration. So just give me a second to just change this. Johan, as soon as you can see my video, would you actually confirm this?
Okay, I can see your camera.
Okay, so this is a nice little demonstration kit that IFM developed for us, and it's used, as you can see, kids' movie cars to actually hype up the application or just make it interesting, I suppose. So we have an Ilink master, and we have each one of those cars with an RFID tag. The black squares that you can see are the DTR 513 that we've been talking about, Ilink RFID readers, and there's little buttons that are the capacitive push buttons, KT series, that we have also on Ilink from IFM. So let me start running this video. The reason that I have this video and I'm not doing this live is just because of logistic reasons, unfortunately. Yeah, but anyway, I'll try the best as I can to actually describe this to you. So the first thing that you will notice is there's a little picture, and I'm actually indicating the Ilink master there and the connection to the IoT port at the moment. You can see my hand touching the cable. Then the actual connection to the PLC, which is hidden behind the actual the demo, and the connection to the RFID antenna on Ilink. Then you've got the little car, and underneath the car, I've got a paper tag. You can see the tag configuration there now in the clear view. And yeah, that's basically what we're going to demonstrate. So I don't need a PLC. There's one connected online here, so I won't be able to write any changes because there is a PLC online here to the device. But I can visualize exactly what's happening. So how do I do that? So I need to actually connect to the IoT port. Then I need to open the line recorded device software. When I open it, after first installation, I get this same view. Then I can go to, once connected to the Ethernet port, I can actually go and find devices, and it'll search for Ilink master, whether it be USB or Ethernet based. So there it's found the AL1320, and it's been installed at the moment. There you can see the IP address now clearly on the left hand side. So when I actually click on it, the unit now, or the software reads from the Ilink master, and will get all its settings. So you'll notice that each Ilink master has a unique device ID. This is specific to manufacturer. Okay, so there we go. So there we have an overview and all the different parameters that we can set. Port 1 to 4, the IoT and field bus setup for IP addresses can all be done on this page. And then you can write those changes to the units. Then on the left hand side, you'll see I've just clicked on the DTR 513. There's two of them connected, and the KT push buttons. There in the parameters, you can see that we have a block size of 4 bytes. We have a 50 milliseconds holdover time. The max block size is 29 bytes, and there's no malfunctions or funnies at the moment, or events that the unit is experiencing at this point in time. We can also restore factory settings if we need, or give it a unique tag number and download it to the unit. So that DTR 513 on the left-hand side would change to whatever you call it. So here in the actual cockpit view, you can now actually test your application and read the tag unique identifier, as well as write a new identifier to it. So you can see now the car I've put in front of the RFID reader, and we've read the tag. Okay, it's a bit of a crazy thing. I didn't realize that the UID is 000 at the moment. And then you could actually, if you wanted to, change the mode of the antenna, etc., from the right-hand side. And on the top here, you can see write all changes to device. So you're in control of the whole application without a PLC connected, just as a one-to-one connection with the Ilink master, which is very interesting. I'm sure you will find. So let me just go back to my presentation now. This will take a second. Jan, can you confirm you can see my presentation again?
Thank you, Anthony. You're back in presentation mode.
Thank you. Right, so how do I connect now the system that I can read, and I can write a new identifier to it just by having a PC and no PLC. But then, yeah, in the applications in the industry, we need a PLC or some sort of controller that we're going to actually connect to. So what is this process like? Well, IFM, the philosophy is to make things easy and close, they're close to your contact. So everything is available off our website. So you just go to www.ifm.com. You go via the products to identification systems and RFID. You can search in that way and then look for RFID antenna, or simply just type in there DTR513. So once I've typed that in, I actually go straight to the data sheet or the technical data sheet of the device. I can also see the price of the device at this stage. Then there's a download menu and a few other interesting pages. For more information, it gives you an overview of what the device is about and somewhat kind of what we've discussed today. But we're interested in the download menu. So we're going to connect this device to our PLC. So luckily, there's a whole pile of standard demo programs for the kind of PLCs that we find on the South African market already pre-configured with documentation. So there's a presentation that comes with this download that'll give you the understanding of how you connect and how the data will look cyclically from an Ilink master through to actually configuring an instrument or an RFID antenna. Very handy. The other thing I must draw your attention to, that every Ilink device has an Ilink description file or IODD file. There's a PDF document that explains what the cyclic and acyclic data looks like. So for example, once you open that PDF document on a website, you'll get a document once you scroll through, you'll get to the cyclic data, and you can see we can capture the mode that the antenna's in at the moment. We can read the tag data in this memory area here, and it's telling you what kind of the data configuration is as well. Very important that you configure your particular word or byte to actually be in this, to accept this format of information. And then you've got an overview as well of what the input data looks like and the output data looks like. So this document is very, very easy to read and easy to navigate through. So there should be no problems with actually integrating RFID via Ilink. So I just want to make a suggestion to you that we have these starter kits on offer. So it's a value add package. So all the items, all the part numbers in this value add package really, if you look at the list price, far exceed what the actual prices of just buying the starter kit. So there's a benefit. Unfortunately, you can only order one per company. So if you order this unit, you have everything to get started with Ilink and to experiment with Ilink and get familiar with it. So I suggest that you take advantage of this offer, because we won't be offering it forever. So I hope that this proves our commitment to you, our loyal customers, with close customer contact. And as always, we offer quality and innovation to take on any challenge together. So I'd like to move on to the Q&A session now. Johan, can you help us with reading out the questions that the attendees have?
Thank you very much, Anthony, for the very informative presentation. And I'd also like to thank all the attendees. It was really a really nice chat box this time around, very interactive from the audience as well. So I've got a few frequently asked questions I'd like to address to you, Anthony. The first one is about the lifespan of a tag. So the question is, what's the difference between an active tag and a passive tag?
Okay, so the fundamental difference between an active tag and a passive tag. So a passive tag is passively looking for a reader to actually excite the coil inside the tag and then read or write to that tag. An active tag has a battery inside, which is transmitting a signal as well. So it gives you an extended range. The lifespan of tags is actually discussed on the sheet. 100,000 cycles, read, write, etc., etc. So you need to actually look at the data sheet of the particular tag to note the amount of read, write cycles. And it doesn't mean to say that it's limited to that. That's just the tested lifespan that has been conducted.
Thank you very much, Anthony. The next question we have is, you've mentioned HF and UHF. Please briefly just discuss what's the difference between HF and UHF.
Okay, so the HF is the 13.5 megahertz range, and the HF is the 800 or 900 megahertz range. So the thing is, it's two different protocols, and fundamentally HF are very close range applications, and UHF, the ultra high frequency, are ranges of greater than 250 millimeters up to 10 meters.
Thank you for the explanation. The next question is regarding RSSI. So please explain the abbreviation RSSI and why would I need to monitor this?
So that's the actual the strength that the actual RSI is the strength of the read that the readers get, or the readers getting back from the tag. So in other words, I hold a tag at its maximum distance. Say the maximum distance is 1 meter away. I get a certain RSI strength back that I can use in the process. So where this is helpful is where you have like AGVs, or you want to read and write to a tag. So let's just deal with the read and write to a tag. So if you want to read and write to a tag, the tag sometimes has a different read and write distance. So to write to it successfully, you want to know that you're in a certain distance away from the reader to make this possible. So you can use the RSSI or the signal strength to actually determine that you're in an acceptable area to actually write to the tag. Or in the case of AGVs, you can actually plot a grid throughout a plant where the AGV would follow the positions of tags, and you can actually then monitor the signal strength as the AGV gets nearer to the actual reader, and actually put the AGV into a different direction, etc. once it actually reaches a certain RSSI value. So hopefully that answers your question.
Thank you very much, Anthony. So the last question I have, there was quite a few discussions regarding the manufacturing of tags and as well as specific applications. So I'm going to try and address all the questions with one question. So is it possible for a manufacturer, if they know the standard of the RFID reader, to manufacture a certain tag for certain applications, specifically for high temperature and these type of applications?
Yes. Yeah, look, there are different standards of protocols, and we have adopted the ISO standard in our range, and there are different temperature ratings for tags. So it's important to note what protocol the tag has adopted in order to know that it will be compatible with the reader from IFM.
Thank you very much, Anthony. So that's all the questions from my side. You may continue with the presentation. Thanks,
Johan. Okay, so now it's just some generic things to end. So please follow us on social media. I'm sure you're well familiar with all these icons. Yeah, there's some nice fun videos or how-to videos that we post on YouTube channel and Instagram channels, which is quite nice to view. And then our webinar schedule is posted on our website. The easiest way to navigate to there is go to our homepage, www.ifm.com/eda, and below the banner that's scrolling, you will find this banner here, and if you click on this portion here, you'll go into a page that will enable you to see past webinars and future webinars. So please be sure to actually have a look at this. So if you miss a webinar or the signal quality is bad during the webinar or something like that for you, don't fear, you can go back and actually upload at your convenience the previous webinar. So another important notice is from Reed's Expo Africa. Okay, so the Automation Africa Fair is scheduled for the 7th and 8th of September 2021. This is always one of the highlights, especially for me, during the year, that we can see all the different manufacturers, innovation, etc., etc. So if you're interested in taking part or exhibiting, you can please contact Eileen Fidley for more information regarding the action-packed fair that is being planned. Further than this, thank you for participating. I wish you all a pleasant day further, and thank you for your attendance. Keep well.